save some time on it. It's a report from Irkutsk, from Kadastrsyomka company. It will be delivered by chief engineer of the company, who will talk about creating digital map bases for the purposes of town urban development and property management. Good afternoon, ladies and gentlemen. In fall of 2013, Krasnoyarsk, a wonderful Siberian city, had the honor to be the host of Winter Universiad. So the city administration was faced with the task of upgrading massively city infrastructure. And for that, maps had to be updated. For most of Siberian towns and cities, there were no updating efforts performed. So the typical problems for the city of Krasnoyarsk was that the city is heterogeneous in terms of accuracy, and there may be a difference in left and right banks of the river. Therefore, there were differences in boundaries of parcels as a result. For mapping bases, map sheets were created in different years, and reconciliation was not always performed. There was only 80% supply of 1 to 500 scale. To address these tasks, several activities were carried out. Initially, a satellite-based height model was created for the city. So this started with creating and making orderly geodetic network. We can see the area distribution at ground control points. There were only 450 points, including 22 third grade points. So creating a single geodetic basis enabled better accuracy and quality of all geodetic efforts, reliable securing of boundaries of parcels of land based on GPS GLONASS technology. Aerial laser scanning of the city was carried out at a height of 600 meters. 6 centimeters was the resolution. Over 17 million points per square kilometer on average. So nearly 6,000 stock sheets were generated. This is an example of a 3D model of the city, colored using point clouds.
Here the point density is 700 points per square meter, so we didn't have the same level of density in the town. In the central part we had up to 30 points per square meter, and 17,018. And underdeveloped areas is 5 points per square meter. Here you can see examples of the actual area photos with a 6 centimeter ground resolution. And as a result, you can compare it with the satellite imagery. Aerial photography proves to be more informative in that respect. We build a digital elevation model for the whole town based on the materials of the laser reflection. We built orthophotos, and everything needs to be done very fast, and these materials became the foundation for the development of the new main plan for the town of Krasnoyarsk and for the development of the road network development. That is why we built the orthophotos and sent these orthophotos to design institutes, and then we built the digital topographic maps and 3D city model. Here you can see the resolution of images. Again, it was the last stage of our project that we did, the true orthophotos. You can see the difference of the same image, same plan, and our main task was to provide the accurate cartographic basis for the design of the planning of the city, and for that we developed first a simplified plan of the road network and topographic vector, so that design institutes could make decisions about how to design new roads and highways. After that, the topographic plans were augmented for a better condition with the elevation and everything. As long as Krasnoyarsk has quite an interesting relief with different altitudes, and which can cause certain difficulties during the interpretation. We used panoramic video imaging with 8 camera setup, went around the city in the densely built area so that we could use these materials during the interpretation stage. Also, we built a 3D digital terrain model. This is a vector model. In stereo, we have digitized the roofs of houses in photomod, and after that we built the structure models, including small architectural forms, and 2/3 of the area of the city. We built a 3D model for all the high-rises that we have. All of them are metrical, with accurate referencing. All of the objects are in coordinates, and you can work with them. Again, this was used by architects during the design of the main plan of the city. These red lines, for instance, what they looked at, and that saw how they can build new houses, what these houses would look like within the existing model. And as long as what we built became the foundation of the currently developed city GIS, the city used this to address their current challenges on how to design the area. Now they're actively using it, how to apply it for other projects. Now we have different layers for different buildings, layers of engineering, communications, roads, topographic plan based on the newly developed plan of the city. And based on these materials, we developed new land use plans now, again based on the same materials. They're working on boundaries and urban development plans, again, road network development, planning of the area, and new construction sites. Also, owing to this new updated information, they follow and monitor the use of lands. We see some of the lands are not properly administered, and within the same project, they monitored what happened in 1 year. We see some of the areas with active construction for some decisions by the government, what needs to be done there. They look at whether they had planning permit or things like that. So the main areas of application here for the single geodesical foundation would be first urban development plans and documents, architecture of the construction, monitoring of the urban environment, land control, some routine checkups. So this is also foundation for some new design and development work and overall management of the municipality. Thank you. That would be the final slide. This is our most recent acquisition, specifically designed for aerial photography. Thank you very much. We'll take only one question. While the questions are being prepared, I will ask a question. What time did you take to do this project? Can you answer this? The whole project took a bit more than 1 year because there were a number of products that we generated. It took us longest to develop digital topographic plans. Up to 30 people were involved in that, and other stages took different time. Rectification, it took us some time for that. What about underground network? Underground was not involved in this. Underground communication, that's a separate event which costs a lot in terms of investigation and mapping. Then later on, the land user services put them on the map. But another question, 3D information that you acquired, 3D model, where did you export it to and where did you process it? And what is 3D database for you? Do you have any form of classifier? What subsequent steps were taken? 3D models were prepared in AutoCAD, standard for most of the design institutes. They work with AutoCADs. According to classification, these 3D models were standardized with SketchUp and others. We didn't develop anything new for that. Thank you very much. I suggest that we break for coffee now. I suggest that